Alright guys, welcome back. Hope you all had a nice Halloween. Got lots of candy. Okay, one thing before we start, the midterm has been graded, as you guys probably saw. There was a problem with the last question and the way it was graded, so we've regraded that question and the grade should be updated now on my courses. A lot of people got some extra marks there. So we're sorry about that, but now it should be fixed. And again, we encourage you to have a look at your midterm, so come to office hours, either my office hours or Chris's office hours, or make an appointment with one of us to come to your midterm. Make sure you understand everything, so that way, you don't have any stuff that you're confused about still moving forward. Okay, and then last lecture I talked about these web APIs and how you could like automate access to all these websites. Oh, by the way, I made an announcement on my courses posting the material, so you can open this notebook on your laptop and follow along. I know the text might be a bit small, but I think this is a much easier way to present the material. So if you want to follow along, you can even be executing the code as you go. So it's on an announcement that there's a link to the notebook that you can download. Okay. All right. So yeah, I was talking about how you could send these tweets from Python and do all these cool things, but that you needed to log in and do some authentications. So in case you wanted to try that out, I put some instructions on how to do that. It's really quite simple. You just log on here and make an account, and then you just copy paste some strings into a function call, and then you're good to go for the rest of this web API thing. Okay, that's that. Any questions for the midterm or anything at all? All right. So today we're going to kind of clarify some things that we've been talking about throughout the course, mainly object-oriented programming, or what's an object in Python, how do you make one, and where do they come from, and why are they there? So when in doubt, turn to the Bible, where it says in Genesis, God made the beast of the earth after his kind, and cattle after their kind, and everything that creepeth upon the earth after his kind, and God saw that it was good. So this is this concept that things have a kind, and that they behave in a way that is appropriate for their kind. Not only that, but this other translation I found says kind of the same thing, but it also says that each are able to produce offspring of the same kind. Okay? So this concept of there being an abstract definition of something, and then actually having instances of that type of thing, like for example, there's the concept of animals, there isn't something that is an animal on its own, there's really just instances of animals, right? So animals all follow this, have all these common properties, right? And they behave a certain way because they are animals. And Python and a lot of other programming languages use this kind of framework or paradigm to define how we work with data, okay? Because it turns out that it makes things really natural if you think about them as types of things and instances of types of things, right? And we've already seen this quite a bit because it's kind of hard to avoid. I also included a link here to Python's little documentation on how types and objects are treated in Python. If you're super curious, go for it, but I think what I'm presenting here should be more than enough. So we've already seen that data can come in different flavors, different types, right? We have numbers, lists, dictionaries, all these sorts of things. And all of these behave differently, right? For example, I can have a list, right? I have a list. I define it like this, and I put an element into the list. And then because it's a list, it has some property, right? Like dogs have the property that they can bark or something like that. Lists have the property that you can append items to them, right? So I can use this function called append that acts on this object called my list, right, which I define here, and I say append to my list. And now if I do all that and I print it, I get a list, that list with another item to it, right? So it's like I've taken a thing that list can do and I've invoked it, and now that list is somehow different, okay? So this append is kind of like a behavior that's typical to lists. But things have to always act according to their type or their kind, right? God would say it's not good, for example, if you have an integer and then you try to append something to it, right? That would be something that goes against what integers can do, right? It's not the way this data is structured, right? So we would get an error and it would say, int object has no attribute append, right? So we've already talked about this whole attribute business a little bit, meaning, objects have these defining characteristics, right? In Python, they're called attributes. And depending on their type, they'll have a different set of attributes, right? So integers don't have this attribute called append. They don't have the ability for you to append an integer to it because it wouldn't make sense, right? So different object types have different attributes according to their kind, right? And we've been using this quite extensively, right? I mean, the whole midterm was, manipulating dictionaries and lists and knowing the difference between them and how they work. Turns out that all of these are objects, and every type of object belongs to a class, right? So the point of today is really to learn, where these things come from and how we can make our own if we can. And just a terminology thing, in Python, when I say type and I say class, they're the same thing, okay? So, think of a class as a category or some, classification, and a type is another word for that too. So, we've learned how to define a function, right? We say def function name, that creates a function and it does some stuff, right? We can do a similar thing with class, right? So we can actually create our own types of data that behave whatever way we want them to behave. And this we really use mainly when we want to manipulate data, types of data that all share common characteristics but are on their own, sort of like individuals, right? So if I wanted to keep a record of all the students in the class, well, you're all students, you all have similar attributes, right? You all have GPAs and you have majors and minors, and I would be able to keep track of you. I would say there's a type called student, and then you guys are all instances of that type, right? You're kind of born out of the type student, okay? So the way we can do that, most straightforward way is you use the keyword class. You give your class a name, foo, typical placeholder name in programming, and then you really don't have to do anything else, all right? You can say pass, meaning pass is the empty Python argument, meaning nothing gets done when pass happens, right? It's just a placeholder. And that's it. You created a class, all right? And now this is a new type that has some attributes and has some properties that you can use. Obviously, there's more to it than this because, this kind of doesn't really do much on its own, but we're getting there. So what we've done is we've defined a class or a type and we called it foo, right? And otherwise, we didn't do much, all right? Now that we have a class, we can actually create objects of that class, right? So they can be born out of this class. Doing so, right, creates what's called an instance of the class foo, all right? So you have a class, which is like a category of things, and anything that's born out of that is an instance of the class, right? So if we had the type or class students, that would describe any kind of student. Any particular student is an instance of the type student. Okay, that's just some terminology. Right, for example, if you had every person is an instance of the imaginary class, he would say. Right? So in order for me to actually create an object or an instance of this class, I've defined the class, right, foo. When Python looks at this, it'll look for my definition up here, right? I said this is a class and it's called foo, and that's all, okay? Now I can spawn out instances of that class, right? Just how, every list is an instance of the class list and every string is an instance of the class list, class string, we can make up our own objects, right? Okay, that didn't run this. I have to execute this. Okay, so I've executed this class definition. Now I want to create two objects of that class. Okay, so I didn't get any errors. Probably things went right. So what I did is just I said class name and then empty parentheses. So the way you create an object is you use the class name as though it were a function. Okay, so you say foo and then round brackets. So it looks like a function call. It kind of is, but it's a little bit of a special function call, okay?
And so Python does not recognize that as the other function. not highlighted in green as other functions are.
Oh, are they usually highlighted in green? Like here?
Yeah. Usually when you print something, it highlights in the
Like this?
Right. So it is a function, but it's not. It doesn't highlight.
Doesn't highlight. Yeah, that's possible. That's really just up to the text editor that decides what to highlight. But it is a function. It's a special kind of function. But yeah, it's technically a function call. Right? So yeah, now that I have this type, I can make instances of that type, right? As many as I want. I can just call this as many times as I want, and each time it would spit out a new object. Okay, it would have a return in there somewhere that returns an object, and that type of object is foo. Okay, so let's just have a closer look at these actual objects that I created. So I created one called my foo and the other one called my other foo, and let's just see what they look like. All right, so I have my f string here. So I'm going to say my object is of type, and then I use the type function. I give it the object that I want to check the type of, and I want to check its ID as well. If it's an object, it should have an ID, so I want to make sure, right? And if I print that out, I get this string saying, okay, my object is of type class main.foo, but basically the type is here, foo, right? So we've created something that has its own type, and it has its own ID, so it's its own object somewhere in memory. This 42 is just because the line, I'm zoomed in really hard, so this should all be one ID here. Yeah, anyway. Okay, let's check the other one. Is it really a different object but of the same class? So I have my my string here where I want to check the ID of my other foo, and I want to check that they're the same type. So I have my boolean inside my curly brackets that's going to get evaluated, right? So I just get the type of the first object, and I compare it with equals equals, and I get the type of the other object. Okay, and I see if those are the same thing, I should get a true, right? And it turns out that yes, they are. So the ID is 4407612192, and the other one was 4407612248. So they're different. They're in different places in memory, but they belong to the same class. So they behave in the same way. Okay. Just how two people can be people while still having different names and different GPAs. All right. So like the ID of an object, the type can also never change. You can't swap the type of an object for something else. That's just constant. If you wanted to convert to something else, you would probably have to create a new object and somehow translate it to that new type. All right. So it's just kind of like a label you staple onto the object. You have its address and you have its type, and those are there forever. Okay. Turns out that classes are also objects on their own. So you can have instances of classes and things like that. Like if I said type foo, I would get that it's of type type. Okay, this is weird. Let's say if I say type ID ID of foo, I would get some ID. So like this class that I defined is also an object, but let's put that aside and not worry about it. If you're super curious about it, it's called it's called metaprogramming. Not going to use that ever. Okay. So a lot happened there when I said when I did this. A lot of stuff happened that kind of went on in the background, and in order for us to understand how objects work, we need to actually see what's going on there. So Python, makes things really nice for us by doing stuff so that we don't have to worry about it. But in order to understand it, we have to go in and see what it is. So let's go and break this down, okay? And we also have to break down this, right? So like, how the hell did this create some new object out of nowhere? Like we didn't write any code. We didn't make a function that returns anything. It's just, somehow worked, all right? Let me see if I can get rid of this toolbar here. Toggle toolbar. Okay, I think that was worse. What? Sorry, guys. Okay. So, what's actually happening is that you don't have to reinvent the wheel each time, okay? Turns out that objects or types in Python are organized into some sort of hierarchy, okay? So kind of like things in real life as well. If you try to understand the world in terms of what type of thing everything is and what, classify everything into some sort of category, you might come up with something that looks like this, which is some sort of type hierarchy, okay? Where let's think of like the most abstract general thing in the world. Well, I don't know, maybe it's an object, okay? Object. Everything fits under the category of object, if we're being simplistic here. Okay, and then we can break that down, right, into, for example, non-living objects and living objects, okay? So those two things are still objects, but they're distinct, right? So they have all the attributes of an abstract general object, but they have their own distinguishing things. If you guys are biologists, some of you, I would imagine, you can think of this as like some sort of common ancestor, right? Every two species can share a common ancestor, right? So they'll have the properties of the common ancestor, but the two species across each other might be somewhat different, right? So this is, you can think of it like this, right? And then you can go all the way down, right? For example, you can have inside of living objects, you can have life forms, right? And inside of life forms, you'll have plants and you'll have animals. And those will also be life form. An animal will be a life form, and it'll also be a living object, and it'll also be an object, okay? And then all the way down until you have, I don't know, a rabbit is a type of animal, which is a type of life form. Okay, so this is the way a lot of programming languages, especially ones that are object-oriented programming languages like Python, there's Java, C++, these are the big ones. They structure their data this way, okay? So let's see what it looks like in Python, all right? In Python, you have something that looks a little like this. Sorry, this is an ugly figure, and it's not 100% correct, so don't put it on your cheat sheets, but it gets the point across, okay? So in Python, we have the most general type of object, which is called object, okay? And that's basically what we got when we just said foo pass, all right? And basically, you can have these other subclasses, for example, bool, string, int, list, dict, function. They're all also objects, but they have their own distinguishing characteristics, right? So as we know, ints don't behave the same way as lists, and dictionaries don't behave the same way as functions, but they all have this common ancestor, okay? And when we come in and we create our own new class, right? For example, this one called this class Natalie, and when you create a new class, it doesn't exist on its own. It's actually some sort of ancestor, or what's called a derived class of the base class object, okay? So when you create a class, it will inherit all the properties of this base class called object, okay? So right away when you say, I define a new class and I don't write anything else, it'll essentially take on anything that was defined by the parent class object in its own definition, okay? So that's why I didn't have to write a whole bunch of code that defines gives it an address and returns a new object and all this stuff, because all it was doing is just taking whatever its ancestor was doing and then using it, okay? And so whenever a class inherits from another one, it's called a derived class. So this would be a derived class of the class object. And then the base class of Natalie would be object because it's sort of its parent class, okay? Its ancestor. And then you can also, for example, make a new class here called Roy that inherits from the integer class, okay? And we're not going to do this in this course, but basically what you can do is, let's say I like how integers work and I want all the cool features of integers, but I wanted to add some extra distinguishing characteristic. I would just extend or inherit from the integer class and add my own little function to it, and everything else gets taken from the parent class. So you can, I guess, like really mutate and speciate, classes from Python that way. Okay. So yeah, this is called a type hierarchy, and this is roughly the way it works in Python. Try to ignore this. This area is a little fuzzy, but basically you can assume that everything, sort of the God class is object, okay? All right. So when we create a new class, it inherits all of the attributes, everything that was defined in the parent class into its own class, okay? So object for the one we created is the base class of foo, all right? So let's look at what it actually inherited, right? When we did that stuff where we created an object and all that, okay? So basically the object class has two important functions that pretty much every object uses, okay? It's called, one of them is called new, and the other one's called init, okay? Let's look at new. So the object class has a method called new, and that's the one that's in charge of creating new objects, okay? So when you call it and you tell it what type of object you want to make, it'll make it for you, okay? So if I wanted to do this more crude, I mean not crudely, but without Python's nice shortcuts, I would have to say something like, all right, I'm going to store this new name here, and I'm going to call the object class, and I'm going to use that class's attribute, new, right? Just kind of how we say string.split or, you know, list.sort or whatever. The object class has this attribute new, which is just a method or a function, and you give it a class, and it'll spit out an object of that type, okay? All right, so that's one step that gets done when you say something like this here, right? So when we did this, man, that's annoying. What the hell? All right. So when I said my foo equals capital foo brackets, right? I was trying to create a new object of that class. What actually goes on in the back is it calls this function, okay? That's already defined for you because it's the ancestor, right? So it says, look, I don't know how to, when you created me, foo, you basically did nothing. So I'm gonna like try to see what my daddy can do and just copy that, okay? So that's what happens here. All right? So right now it's kind of, it's spat out this object for us, and it's sort of like a blank slate, okay? There's nothing to it really, because it was inheriting from the object class, which is like super bland. There's nothing really unique about it or sort of identifying about it. So it's some sort of blank slate, all right? And then in order to make our objects actually interesting, we want to give them some useful attributes, right? So this is what's done by the function called init, right? And what it does is it initializes an object. By initialize, I mean it gives it some defining characteristics, right? So the object has been created, and then the initialization function just kind of molds it and gives it some data to work with, okay? And basically, it's just a function, right, called init, and it accepts mandatory one positional argument called self, or whatever name you want, but basically this is an instance of the class, right? So here, my foo, and I use the new function, that spat out an instance of the class foo, right? So then I would be able to use this instance in my initialization function to set some attributes of it, okay? That way, once we figure out how to do that, we'll be able to do things like, for example, here, when I say x equals 5, oops, that should say x, right? It turns out that integers have these attributes called numerator and denominator. I don't know why they're useful, but like they give you what the numerator would be of this number. So if I give it 5, it would tell me the numerator is 5 and the denominator is 0, which, I mean, doesn't make a lot of sense. But anyway, it's just to show that there's attributes of these classes that we've already been working with. Basically, these ones get set by the init function, all right? So step 1 is you create the object with the new, and then step 2 is you give it some data, some attributes, some defining characteristics with the init function, right? So when I do my foo equals foo, what's happening is Python's looking for the new function, calling it. This new object gets created out of nothing, and then that object, it gets given some name, some whatever you want, using the init function. So two functions get called by this one piece of code, all right? So basically the init method, what it does is it sets the attributes of the object, right? So if you were to look at the code for the integer class, there would be a part of the init function that says like, you know, self, right? It will take this object and say self.numerator equals 5 or something like that, okay? Yeah, so obviously the way we've been creating object, like the way you can create your own predefined objects is like this, by calling the class name explicitly. Obviously, this also creates an object, x equals 5, but this is kind of a special type of object, so Python said, you don't want to have to call integer class every time you create an integer. You can just write the number and it'll do the rest for you, right? So all these classes that we've been working with, they have their own shorthand ways of creating instances of that class. But when you want to define your own, Python doesn't know any shortcuts to creating your object, so you have to use the class name and this function call basically, right? But essentially they're doing the same thing, right? When I do this, I might essentially, I would have to replace this with like a, integer, and I don't know, I would say like 5 or something. This is not, I don't think this is the actual way to do it, but it would look something like that, okay? Okay. Everything clear so far? All good? All right. So, now we know what's happening. Now we know that there's these two functions being called, right? It will look something like this. When I try to make a new class, when I do this, right, super shorthand, Python goes and says, all right, well, I'm going to look into the object class and I'm going to use its attribute new, and I'm going to give it this class foo that it's the type I want to create, and I'm going to spit out a new object, right? That's going to be in here in this name, and then I want to set some attributes to it, so I call the init function on my new instance of the class. Okay. So this is cool, but I mean not super useful, right? I mean the object class really is sort of like a very big umbrella that anything can fall under it. Really, we'd want to define our own type of class that has some useful data to it. So what we would do is, instead of using our parent's init function, right, we would use our own. Okay, so we would define our own function. And now let's upgrade our class definition to look something like this. Okay, so again, we have the same thing. We say class foo, but now we're going to go ahead and do some extra work and define our own init function. Okay, so when you create an object, Python's going to first look at the definition of the class to see if you've made your own init function, right? The new function you don't have to touch usually. It's the process for creating an object is usually the same for every class, so that you can leave on its own. It just spits out a blank new object. But what you usually modify when you create new objects is this init function, right? Because you're just setting some attributes of the object, right? So so you're assuming here that you've received a new object from this class, right? You're assuming that the new class got called somewhere in the background. Sorry, new function, right? 2 underscores called before this, right? And spits out instance, right? So essentially that instance is going to go into here. So it's like a little factory, right? You make your little blob, and then you send it over to the init function, and the init function stamps some data to it, right? And what we're going to stamp to it here is just going to be some name, all right? So we're going to say, look, this objects of this type are going to have an attribute called name, and that attribute is going to be some value you pass to me, right? It's going to be n, all right? So when I want to create a new object, right, I can now say, all right, here's my class name, right? So that's the type I want to create, and I'm going to pass as input some data, right? So for example, my name here, and that's going to go into the init function here, okay? So now n is going to be given the value Carlos, right? And it's going to set the attribute of this object to Carlos, the attribute name to whatever value was passed by n, right? So it's just like it's a normal function call. The only weird thing, right, is this sort of self thing, right? You don't actually see me passing in something here, right? Usually, actually always, this first argument is implicit. So Python throws it in there for you, right? So when you do this, it creates the function, it creates the object, and it gives you this object, and it passes it in so that it can go right into the init function, okay? You'll get used to this. It's a little weird, but you'll get used to it. Right, so now I have this object, or I could have called it whatever, like whatever. And I can say whatever, okay? It's just a name. Self is used by convention because it refers to the object that's being created, so myself, kind of. And then I just set its attribute to n, all right? So if I run this, Okay, I'll redefine my class here, and let's create a new object, and let's give it some interesting data now. So now I have an object, and hopefully I can access its attribute that I defined, name. And yeah, so now this type I've created is some type that now has a name, right? So I can give any string here, right? I can say Chris. And now anywhere in my code, I can, if I have something of type foo, I know that it's going to have this sticker, this attribute name, and I can always call it and obtain it, right? Okay. So, yes?
So the dot name is you create a new attribute inside class, you should call it anything. Like you could call it dot another attribute. Yeah. So equals to.
Right? And now you're going to have two attributes in this class. And I'm going to give Chris's age, which is 50. I have to rerun it. And now Chris has two attributes. Right? So, oops. Right, so let me just print. Okay, so yeah, there we go. Yeah, so you can pick as many attributes as you want to give your class, okay, your type. You just have to put them all in here, all right? Okay, let's not offend Chris here. Let's bring it back down to 20. Okay. So what we did is we've defined something called an instance attribute, okay? Meaning that any instance of this class is going to have that attribute, okay? And you can have multiple instances of a class, right, as we saw, and they'll all have different values for that same attribute, okay? So that's why the value of that attribute is specific to an instance of the class. So I'm saying a lot of words that are new. You'll get used to them though, especially in this next assignment. So imagine now I have, now I have to give these guys ages. Okay, so it's, I don't know, 400 and like 600. Okay, because now I changed my definition to take two arguments, so now I have to give it an age. Right, so now I want two objects of this class. I'll take Plato, and I'll say his age is 400, and Socrates, his age is 600. Probably way more than that, actually. I don't know, something like 3,000. Okay. My history is not very good. Okay. No, they're around the same time, I think. Okay. Let's give it. Okay. So, invalid syntax. Oh, I stuck this thing in. Okay. All right, so what's happened now is I've created two instances of this class. So they both have the same properties. They both have a name. They both have an age. But they have different values for these attributes, right? So obviously Plato's name is not the same as Socrates. So I can say something like a.name and it's going to give me Plato. And I print b.name and it's going to give me Socrates. So you've just kind of created these two different, instances, right? So they have the same attribute on them, but they're going to have different values because when you created them, you specified a different, value for that attribute, right? Let's just for fun print their age. Okay. All right, so this is going to be really handy, right? Like if you're defining some sort of data structure or something, and you want to have some quick way to access some aspect of its data, you can just define an attribute for it and just say, I want this DNA's sequence or something. So yeah. So A and B are both instances of the same class, right? But they have different values for that same attribute, which makes sense, right? All humans have legs. They don't all have the same number of legs, so you can have a field for the number of legs for each human, right? It doesn't make them less human if they have less legs or more legs. So, all right. Okay. So we saw that instances can have attributes. But it turns out that classes can also have attributes, okay? So whereas instances are kind of unique on their own, a class is sort of like this umbrella, this container, right? So if I were to define some object up here in the class level, this piece of data, so let's say I'm defining a class that describes a family now, okay? Oh, sorry. Yeah, okay. So I say class family. And before I do my init, right, here with the init is really working on instances of the class. But if I do something up here, I'm defining something about the class in general. So let's say a family, has an address, right? They live at this address, and they have some number of family members, okay? So every instance of that class is going to have the same value for that attribute, right? If this family all lives in the same house, they're all going to have the same value for their address, right? So that would be a property of the entire class, right? So just in the way that, I don't know, all quadrupeds have 4 legs, that would be a class attribute. They don't all have the same DNA specifically or whatever, right? So you can define attributes at the level of the class, basically, right? And that'll just give you some information generally about that type. So if I create, 2 members of this family, Alice, right, I give her a name, Bob, I give him a name, right? So these are now 2 instances, and now I'm going to be able to remember that this one's name is Alice, and I can easily access it, because I know that they have the label name there. I can also do something cool. For example, let's say if I want to keep track of how many members are in the family, right? So what happens? I define this class level attribute here, which is address, which I can access, for example, doing this. I can say the class name. Instead of an instance, you give it the name of the class, and you say .address, right? So obviously that address is going to be 1234 Elm Street, and no matter who you are in the family, you have the same address. So you're not really working with instances here. You're really working with the general type, all right? And let's say every time I create an object, I want to increase the count of members in my family, right? So because I know that the init function gets called every time I create a new object, a new instance of the class, I can stick in this little piece here that says I'm going to modify the family class attribute.family members. I'm going to add 1 to it, okay? So every time this function gets called is every time I create an instance. So for example, it'll get called once here, then again here. So this would be adding 1 to this class attribute. And now every time I create a new instance of this class, I'll increase that counter, right? So I'll always know how many members are in my family, right? Let's say I added 1 Chris, right? 5, okay, yeah, of course, because I didn't reset this. 3, okay? All good? Yep. Yes, you do actually. Yeah. I didn't think you did, but it turns out you do. So this should give an error. Yeah. So it can't find it. So you would have to say family members. Yeah. Good question. Okay. So basically what the initial init function does is it makes sure that whenever you create an object of that class, they all have at the very least the same type of attributes, okay? So I know that every time I create a family member, they're for sure going to have a name, right? If I tried to call this class, create this object family without a name, I would get an error saying you're missing an argument here, n, right? So I have to give it a name, okay? But, so this just makes sure that every object has some common ground, right? You're not going to get any weird family members that don't have a name. But let's say like not all family members need to have some other attribute, like for example, okay, sex, right? So let's say I only want to keep track of Alice's sex for some reason, okay? I can say alice.sex equals f, okay? So this creates a new attribute for that instance, and it sets it to f, right? So now she has 2 attributes. She has a name and she has a sex. But the other instances don't. So if I wanted to see what Bob's sex was, he doesn't have one, right? So all that to say that the init is kind of like a bare minimum so that they all share some common ground. But later on in your code, you can always add an attribute to an instance, okay? Okay, now moving a little closer to biology. So let's say we wanted a class that lets us deal with DNA sequences, in a much quicker way. This is actually, in Python, there's a class that does this for you, but, and we'll talk about it next week, I think. But basically, we wanted to do something similar ourselves. So we'll define a class where, all instances of this class are going to have some properties that can be thought of as DNA properties, okay? So, what do all DNA things have? Well, they all have some sort of sequence, right? Some, A, C, T, G, whatever. So I'm going to make sure that whenever I create a DNA object, that it's going to have some value for this sequence attribute, okay? Little note, actually, you can also, so you see how I say self.sequence equals seek, right? Seek is just whatever gets passed to me when I create the object. You can also say, like, they can have the same name, actually. And Python will know the difference, right? So this works too. You'll see that many times, self.sequence equals sequence. This is referring to the attribute of the object. This is referring to the input to the function, okay? They have the same name, but they're different things. So that would work too. All right. So we've got our initialization. We know any DNA object is going to have a sequence associated with it. And we can also actually define methods inside the class, so or functions, rather. So these are also things that we've seen already, right? For example, a string, you can say string.split, and it's going to split up your string by spaces, or you can say, I can't think of anything else right now, but that's an obvious one. Or sequence.sort or something like that, right? You can sort a sequence. So these whenever you say dot something, that means that you're accessing an attribute of a class, right? So and it happens that attribute is a function, and we do that here. So once you're done your init, you can add any number of functions you want. So for example, if I want to compute the GC content of this DNA sequence, which is something that people are typically interested in, which is just how many of the letters in the DNA are G or C, the fraction of them, the proportion. So if I have all G or GCs, then I would have 1 as in 100%, or if I had all A's and T's, I would have 0 GC content. So if this is something that I'm interested in computing for my DNA sequences, I can just define it as an instance method. So when a function acts on an instance of a class, it's called an instance method, not a function. This is just terminology. It's still technically a function with input and output and all this stuff. But what happens is it always requires an instance of the class for it to work, all right? So compute GC wouldn't make sense if you didn't give me a DNA object for me to work on, all right? So I'll define it here, and then we'll see how it works. So, so this function takes as input self, which is an instance of the class DNA, right? And then all it's going to do is going to return the length of this list comprehension, which all it does is it goes, for every nucleotide in self.sequence. So whatever object is called, this function is called on, is going to have a sequence attribute because I know they're all DNA instances, so I can access that object sequence. And then if the nucleotide is either G or C, then I add it to my list, and then I take its length, and then I just divide it by the length of the sequence, and that's going to give me the fraction of G's or C's I have in that sequence. Right? It could be whatever, right? I could just return some random number, but basically trying to make it biological. So we create our object here, all right? D equals DNA, so it's going to be a new object of type DNA that we've just made up. And in order for me to create it, it requires a sequence to be specified. So I just give it a string. That's this ACCGG. Okay. Useful thing to know is this function dir, dir, and then you give it an object. Tells you all the attributes of an object. Okay, as a list. So it has all of these things that are sort of predefined for you. Everything with an underscore is usually something that's been built for you. And the ones that are interesting here are, for example, the ones that we created now. So compute GC and sequence. So we've defined this function, and it's become an attribute of this object. Okay. So now we can just say, all right, I have this sequence D. I want to know what its GC content is. I can just say d.compute GC, and it's going to give me that it's 66% G's and C's. All right. Is that clear? Right. So these functions always require an instance of a class to work. So essentially, whatever this B is, right, whatever comes before the dot is actually passed to the function as that self, okay? So anything before the dot is actually what gets stored in self. And then inside the function, you can use it because that's the object, so you can access its attributes, right? Self.sequence, that's how I was able to compute the sequence of that, the GC content of that sequence. We can do crazy things too, like just the way that we wrote our own init function, instead of using the parent init function, we can write our own add method, okay? So this add method is defined for you, usually, but you can write it yourself and change it somehow, right? So let's make a new class called weird number, okay? It'd be a class for weird numbers. And this type of object is gonna have an initialization function where I'm giving it an attribute called num, and it's just gonna be equal to whatever this n is that I get. And I'm gonna define this underscore underscore add function, right? That takes in the object before the dot and some other object, okay? And what it does is it returns self.num, so the value of this attribute divided by the other guy's .num attribute, okay? So now I'm going to initialize two of these weird numbers, all right? And so I initialize this one with the value 3. So if I said w.num, I would get 3. And if I said x.num, I would get 2. And now if I do w plus x, I get 1.5. So like, it divided. If it's actually doing the normal addition, this would be 5, 3 plus 2. But actually, because I overrode, I like said, you know what? Don't use the parent's add. I'm going to use my own. Basically, the plus operator knows to call the add function of an object, and basically now it divides the two numbers instead of adds. So, pretty weird. Don't have to worry about this too much. Just kind of a cool feature. This is just more information on instance methods, right? You always, yep.
And so you overrode the add function.
Yeah.
For this particular
Yes.
object, right?
Yeah. If I say
that is like
4 plus 3 is still 7. Yeah. So it looks at the type of object that's being added, and it says, I'm going to look at this object's add function, right? And it looks for the nearest definition. So because the nearest definition of these two weird numbers is add, like it doesn't have to look at the parent, then it just uses this one. But because in the integers I didn't redefine it, it would use the integer's add definition, right?
Okay, so if you would redefine the add in the integer class.
Yeah, you could change the way that works. Yeah. Never do that, but yeah. Okay. Yeah, so instance methods always take as input an instance of the class, like I told you, and it's usually given by the first positional argument, which is self, right? That's just a little demo of that. I already went over it. And yeah, so I just have here a little summary of what we went over, and I wrote the midterm question for the library in object-oriented programming, so you can see how it works, see a more elaborate example of that, try it out yourself. Let me know if there's any bugs. There probably are. So yeah, the idea was to make the same functionality, but instead of dealing with all these dictionaries, you would have these like convenient attributes that you can use, right? Instead of indexing on dictionaries, it's all there. So yeah, usually, if you're doing some repetitive task and always, you're noticing that you're always trying to store the same types of data for many different types of objects, you might want to define your own class and make things a little easier for yourself. Assignment 3 is very much practicing this, and I think once you understand this lecture, you're good to do the whole assignment. So I recommend you guys get started. Yeah, any questions? All right, see you guys Friday.